Good morning everyone. This is Mr. DHAKSHUNHAAMOORTHY, Assistant Professor in the Department of Artificial Intelligence and Machine Learning. I am handling subject 21 CS 302 Computer Organization and Architecture for the class 2nd year 4th semester. Today's topic is cache coherence. Even then we are using cache memories for improving the processor performance. Sometimes whenever we are going to the multiple processors, in the scenario cache coherence problem is happening. We will discuss this with some examples also. Caches in the multiprocessing environment introduce the cache coherence problem. When multiprocessors maintain locally cached copies of a unique shared memory location, any local modification of the location can result in globally inconsistent view of memory. The cache coherence schemes prevent this problem by maintaining a uniform state for each cache block of data. For example, shared memory holds the variable shared memory location as some variable x which holds the value 24. This is accessed all the 3 CPUs. Here internal caches is getting updated this shared memory value. Now processor 1 reads x, obtain 24 from the memory and caches it. Now CPU 1 holds 24 for the variable x. Processor 2 reads x and obtains 24 from the memory and caches it. Now we don't have any problem. CPU 1 and CPU 2 caches having same value in their caches. Now the processor 1 writes 32, modifying the cache variable x value to from 24 to 32. It is locally cached copy is updated. The processor 3 reads x. What the value should it get? Since CPU 1 variable x value 32, it is not getting updated in the shared memory, and also it is not reflected in the CPU 2 and 3 caches. Now processor 1 thinks it is 32, the memory and the processor 2 thinks it is 24. Inconsistency in data sharing. Suppose 2 processors use or read a data item x from the shared memory, then each processor cache will have a copy of x that is inconsistent with the shared memory copy. Now suppose one processor modifies x to x dash. Now that processor cache is inconsistent with the other processor's cache and the shared memory. With a write-through cache, we are providing some solution. Write-through cache, the shared memory copy will be made consistent, but other processor still has an inconsistent value x. With a write back cache, that means once the shared memory is getting updated, it is eventually when the block containing x is replaced by x dash or invalidated. Inconsistency in data sharing. Here we can see the 3 different scenarios before update. Inconsistency problem is not there. Processor 1, processor 2, memory, all having value 24 for variable x. When processor 1 is getting changed, some value x to x dash, then write through cache. Here what is happening, the processor 1 x value is updated into the memory, but that is not reflected in the processor 2. Next we are trying to do some more way to reduce that inconsistency problem. For that, what we are doing is write back cache. Here the processor 1 is getting changed from x into x dash value, then it is getting reflected into the memory write back cache. That means the memory once getting updated, that value is reflected whatever the processor is connected with that memory, so that inconsistency issue is overcome. Process migration, transfer of sufficient amount of state of the process from one processor to another processor. The process executes on target processor. The process migration is done in the case of load sharing, heavily loaded to lightly loaded processor. Inconsistency after process migration. If a process accesses variable x, resulting in it being placed in the processor cache, and is then the moved to different processor and modifies x to x dash, then the caches on the two processors are inconsistent. The problem exists regardless of whether write through cache or write back caches are used. Inconsistency caused by I/O. Data movement from an I/O device to a shared primary memory usually does not cause cached copies of data to be updated. As a result, an input operation that writes x causes it to become inconsistent with a cached value of x. Otherwise, similarly, writing data to an I/O device usually use the data in the shared primary memory, ignoring any potential cache data with the different values. Thank you.